On example 11, it asks us to solve simultaneous equations that involve indices. So we have two separate equations. We have 32 to the x divided by 8 to the y equals 512. And separately, we have 3 to the 3x divided by 1 over 27 totally to the 1 minus y equals 729. So simultaneous equations ask us to think about these equations separately, but they are going to have a common solution once we find how to relate x and y together. Right now we can't do that. So the goal immediately is going to be to simplify each side so that we can make a relation between x and y. So because we have our exponents as variables, we have to turn these things into the same base. And so we have to look at each side and determine which base makes sense. So on this side we have 32, 8, and 512. Well, 8 squared is 64. It's not going to make 32. So we've got to think of something smaller. The only one that makes sense is the number 2. 2 makes sense. 2 to the 5th power is 32. So we have 2 to the 5th to the x. Now, I'm going to do this divided by sign I don't like. I'm going to make it like this. Is 8 to the y. 8 is the same thing as 2 cubed. And that's going to equal 512. Well, 512 is going to be, let's see, 2 to the 6th is 64, 2 to the 7th is 128, 2 to the 8th is 256, and so we have 2 to the 9th power over here. On the other side, we have 3 to the 3x, and 1 over 27 to the 1 minus y, and 729. All of these are divisible by 3. 3, 27, and 729. So I'm going to say this is 3 to the 3x divided by 1 over 27 to the 1 minus y. Okay, so 1 over 27, that's the same thing as 1 over 3 cubed. Now, how do I write that in terms of just a regular 3? Well, this is the same thing as 3 to the negative 3. Right? If we're dividing by something to a power, we can make it a negative power and think of it as multiplication. And so we're going to have 1 minus y here. That's a big step. It's going to make things easier on ourselves. And then this is going to equal 3 to what power? So 3 to what power makes 729? Well, 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81, 3 to the 4th is 223, and 3 to the 5th makes 729. So this move here is so that we can get all of the bases to be the same. And then what we're going to go do from here is we are going to simplify and move down to where we get the same base on each side. So 2 to the 5th to the x is the same thing as 2 to the 5x. Remember, when we add exponents, when we take an exponent to another, we multiply. This is going to be divided by 2 to the 3y. Same idea. Makes 2 to the 9th. On the other side, we have 3 to the 3x divided by 3 to the... Now what do we do? So we have to do negative 3 times 1 minus y. Negative 3 times 1 makes negative 3. And negative 3 times y makes a positive 3y. And that's going to equal 3 to the 5th. So we still don't have one base on one side, one base on the other. We kind of have this thing stacked on the other side. So we kind of have to keep moving. So when we know we're dividing by a same base, we subtract the exponents. What we're going to have here is 2 to the 5x minus 3y equals 2 to the 9th. And on our other side, we have 3 to the 3x minus what we have on the bottom, which is negative 3 plus 3y. Now notice how I put the bracket there, because we're subtracting the whole thing. And when we subtract a whole thing, we need to make sure that we account for the fact that signs may switch. Now, what we're going to see here is that if we do negative 3 makes a positive 3, and a negative positive 3y makes a negative 3y. So this becomes plus 3 minus 3y. So we've gotten to this point now where we have the same base, we have the same base on both sides, and we can make a statement about our exponents. We can say that 5x, minus 3y equals 9. And we can say that 3x plus 3 minus 3y equals 5. So this is great. We've gotten to a point where we can make a clear statement about what we have. Now, if we have simultaneous equations, there's multiple ways to deal with that. Now, if we have our calculator handy, this makes it very easy. What we want to have written is we want our x's in one column, we want our y's in another column, and we want our equals some value in another. So if we pull this from this side, we're going to have 5 minus 3 equals 9. This side needs a little work. So this is going to become 3x minus 3y equals 2 if we subtract that over. So we're going to get 3x minus 3y equals 2. Now this is a matrix, and probably the quickest way to do simultaneous equations is with a matrix. And so what we're going to do is something called the RREF. It's called row reduction. And so we're going to create a matrix, do the RREF with this set up, and then we're going to get our answers out. So what you're going to need is your calculator. So I'm going to open my calculator up. I'm going to shrink it down so you guys can see it. So I'm going to go into my matrices. I'm going to edit. And so I'm going to make it's row by column. So we have 2 rows by 3 columns. And I'm going to type in the numbers exactly as I see them. So 5, negative 3, 9. And I'm going to have 3, negative 3, and 2. So how do I do a row reduction? So I'm going to go and say, okay, second matrix, I'm going to go to math. If you move down your list, you'll see one that says RF. Yours may be in a different place than mine, but it'll be towards the bottom. And I'm going to do a row reduction on matrix A. When I do that, I get 3.5 and 2.8333333. If I then kind of blow this up and show my fractions, I'm going to end up with 7 over 2 and 17 over 6. Well, what does that mean? Well, if you look at the matrix, it's going to say 1, 0, 7.5. Well, the way I set up my matrix on the left side is that I'm talking about x first. So x equals 7.5. And I did my y second, so y is going to equal 17/6. So I get x equals 7/2 and y equals 17 over 6. This is how we do a row reduction. The process behind it is very complicated. Now there are other ways to do this, but this is by far the fastest way when you have simultaneous equations. So if you have them and you have your calculator handy, use this feature. It saves you lots of time, and it's very, very accurate. It's much better at it than we are at doing row reductions.